This is the joy of food waste. And as you can see, it's food, it looks horrible, however, it's a nice mix really of carbon and nitrogen. So we get the carbon from the vegetables and we get nitrogen or high proteins in the meat. So it actually looks quite good. And I think everybody's feeling quite sick with the smell, so we'll move down.
We're here today to have a lesson all about energy. The energy that runs everything around us. The stuff that possibly your parents grumble about because they have to pay for their energy, their electricity and their gas. Now, with biomass energy that we get, we use it ourselves in the food we eat. We have a problem. When we get leftover biomass, pieces of leftover food, we have tended to throw all of that food into landfill sites. And what we've come here today is to find out a better way of dealing with that waste food material. It's called anaerobic digestion, and we're here today at Langage Anaerobic Digestion Plant, and we're standing on top of large tanks that digest that waste food. And to help us understand, first of all, I'd like to introduce a colleague, Dr. Kevin Hughes.
If you think of the waste that comes out of your house, we have garden waste maybe that could be turned into compost by a certain type of bugs and bacteria. We have the plastics and the metals that can be moved to the side because they can't really be dissolved. But we also have all the other stuff, the smelly stuff. Imagine your kitchen bin, and that stuff there can be eaten and consumed by anaerobic bacteria. And these ones that don't need oxygen, they just sort of chew up the waste and they produce gases by chewing up that waste.
Perhaps, Gary, if you can tell us a little bit about the motivation. Why did you make this amazing power plant?
Well, some years ago, we still are a dairy, and we actually produce clotted cream and ice cream, which are our main products. But we were generating waste. Whenever you make a product, you generate a waste, and we needed to find a better option of just throwing this waste away. So we had a look at different technologies out there, and we took a risk on going into anaerobic digestion.
I have to tell you, the smell is rather strong.
So at this point, it goes into the machine we saw earlier on, and it gets split into two fractions. One you can see behind me is the packaging. So that's all the bags and the containers that were in there, and the machine we were looking at upstairs, it splits it into two. So the plastics go into one, and then we send that off to MVD, which is an incinerator. And then the organic fraction actually travels down that chute there, and then we compress it, we heat it, and the reason we heat it is we need to cook it. And we like to cook it so all of the bugs that are in there, they aren't necessarily the ones that we want. So we pasteurize it. In terms we pasteurize them just like you milk at home. We kill everything, and then we add the bacteria that we want, which is essentially from a cow's stomach.
I think we're going to go outside where it's a little bit quieter, and we'll be able to also get some nice fresh air. And I'm going to very, very quickly just speak to Kev for a little bit about the future of anaerobic digestion. Hopefully you've seen how cool this place is. Really does smell, but it's very, very cool and really important to use up the food waste. Kev, can you tell us a little bit about where you see this going? Do you think we'll have these everywhere? Will we be processing food waste in this way everywhere in the UK?
Yes, we will. The future of anaerobic digestion obviously relies on the future of waste streams, and there's so much out there that we don't actually take advantage of at the moment. It will be a massive industry if we actually manage to collect properly and collect everything that we can collect and fully utilise it, rather than it going into landfill or waste elsewhere. But we need to do it across the country, and all different sizes. We've seen a big plant here where there's lots of places where they could do it in small scale, little microsystems, and that's probably one of the main challenges now, is tackling the microsystems. So you'll see these a lot more across the country. We have very few of them in this country. For example, in India, they've got about 4.6 million of them. Wow. You know, they're done all over the place, in people's gardens, in market stalls, everywhere.
So we need to catch up in this country,
we do,
I think.
yes.
Ewan, we've got these kind of wood chip piles here and this big kind of green
Okay,
tank. What's going on there?
biofilter. And what happens is the two pipes suck air out, so we've got negative pressure on the building, and that sucks out all the odour, obviously not all of it, because you smelt it. And the air goes underneath the biofilter, comes up through it, and the bacteria eat away at the odours. So that's one of the compliance things I've got to deal with. This one here is the engine. So the gas goes down this pipe, round the back, and goes into the engine. That generates electricity, which you talked about before. But the extra thing with this is the exhaust. Instead of releasing it to the atmosphere, it goes into a boiler. And that heats up water, which we use for pasteurisation system.
Fantastic.
So nothing's really lost.
Brilliant. So you've got electricity and some heat out of there. Fantastic. Yeah. Combined heat and power, really important in engineering. Thank you so much, Ewan. Let's pass over to Alice to get your careers questions answered.
Arthur wants to know what gets produced when you burn methane. And actually, you've just seen the engine over there. So
okay.
yeah.
It's actually CO2. Now, that sounds really bad. But as was mentioned earlier on, methane is 27, 28 times worse than CO2. And what we do is we convert that from 28 times worse down to 1 instantly. But again, the only carbon that gets absorbed or gets released is the amount of carbon the plant absorbed from the atmosphere whilst it was growing. So it is absolutely carbon neutral. We can't make carbon, we just recycle it.
Maybe we could just have a little very quick summary from each of you of how you ended up in this, because none of you started out necessarily dreaming as a 5-year-old of getting into AD. So yeah, maybe if we go around quickly and each of you says sort of your path into this.
Well, I joined the Navy, I left Wales and joined the Navy at 16 some years ago. I did my career, and whilst in the Navy I became an engineer. And I managed to use all of those skills I learned there in AD.
When I left school at 17, I decided to join the Royal Air Force. So I went there for 30 years, flying around in aircraft and enjoying myself, and then decided that I wanted to change. And I saw renewable energy engineering, which was starting to become quite interesting and coming to the forefront. I actually went to university at the age of 50. This is where I met Adam, who was on the same course as me. And there, learned to be an engineer, and as I came towards the end of it, they asked me if I'd remain and do a doctorate in a certain aspect of anaerobic digestion.
Yeah, so I joined the Army, 18 for 22 years, came out of that, did construction for a couple of years, and then became a tattoo artist. Did that for about 15 years and got into environmental health. Did a degree on that and came here as an operator. I think I was operator for about a year, and then Gary offered me the opportunity to become compliance manager, and that's what I've been doing for the last couple of months now.
Thank you so much for listening. We hope you've got a lot out of this and really enjoyed meeting these people from really interesting backgrounds, all doing something fantastic for the world, generating energy from stuff that we just chuck away. It's brilliant. So, Adam.
And a 20-second recap of what we've learned today. We've learned what anaerobic digestion is. It's a fantastic way to prevent the methane gas from food waste going into the atmosphere. Instead, we capture it, we use it, we turn it into useful energy. And most of all, you've learned what fun it is to be an engineer. It's a great career, and I encourage you all into engineering to develop, build, and run amazing plants like this.
And that's it. Thank you very much from all of us here.